Good morning, everyone. My name is C. Esther Verma, and my co-author is Dr. Pooja S. Prasad. And today I'm going to give a review of supervised and unsupervised machine learning approaches. So, what is machine learning? So, according to Herbert Simon, learning is any process by which a system improves performance from experience. So here machine learning can be called as an application of artificial intelligence that involves algorithms and data that automatically analyze and makes decisions by itself without human intervention. So we can say that machine learning is artificial intelligence that is generated on the basis of experience. Now the difference between traditional programming and machine learning here is in normal computer software, a human developer gives codes or programs that instruct the system how to react to a situation, but in machine learning, uh, the system is trained by a large number of data. So when do we use machine learning? So whenever human expertise does not exist, and when humans can't explain their expertise, when models must be customized, and models are based on huge amounts of data. So this is an example of where we need machine learning. Here we want to identify the number 2, and it is difficult to identify uh, when we have different set of handwriting. And there are a few more tasks that are best solved by a learning algorithm, like recognizing patterns, generating patterns, recognizing anomalies, and prediction. Some sample applications of machine learning are web search, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks, and debugging software. And these are some real-time examples of machine learning, like traffic prediction, virtual personal assistant, online transportation, social media services, email spam filtering, product recommendation, online fraud detection. Now, let us see the different types of learning. So we have 3 types of learning: supervised, unsupervised learning, and reinforcement learning. So supervised learning involves a series of functions that map the input with the output based on a series of input-output pairs. For example, if we have a data set of 2 variables, like one being the age, which can be the input, and the other being the shoe size, which will be the output. So we could implement a supervised learning model which would predict the shoe size based on their age. So further, this supervised learning algorithms are categorized into 2 parts, which is regression and classification. And here we have unsupervised algorithms also, wherein we do not have labeled data. So here this is an example of the diabetic and non-diabetic patients based on abstract data. So the 2 subcategories of supervised learning are regression and classification. So generally regression is used when the predicted data is numerical in nature. In regression, we find the target value based on independent predictors. So that means we use this to find the relationship between dependent variable and independent variable. And in regression, the output is continuous. The most common type of regression model includes linear regression, which is simply finding a line that fits or best fits the data. Now, its extensions include multiple linear regression, that is finding a plane of best fit, and polynomial regression, that is finding a curve for best fit. Now, the next one we have here is the decision tree. Here, each circle that we can see is called as a node, and the more nodes we have, the more accurate the decision tree will be. So we use decision trees to take a decision and classify the data into different classes. Now the next one is the random forest, which are ensemble techniques which are built of decision trees. It involves creating multiple decision trees using bootstrapped data sets of original data and randomly selecting a subset of variables at each step of the decision tree. The model then selects the mode of all the predictions in each decision tree, and by relying on majority wins model, it reduces the risk of error from individual trees. The next one is neural networks or artificial neural networks. So, which is a multi-layered model inspired by human mind. Like the neurons in our brain, the circle represents a node. So here, layer 1 represents the input layer. The next two layers are the hidden layers, and the third one, or the fourth one you can see here, is the output layer. So each node in the hidden layer represents a function that the input goes through, ultimately leading to the output. Then comes the classification. So here the output is discrete or categorical, like we have a yes or a no or a true or a false. So some of the most common type of classification models include logistic regression. So here this classification shows whether the cancer is malignant or benign. So here we have the logistic regression, which is similar to linear regression, but is used to model the probability of a finite number of outcomes. So typically we have the outcomes which lie between 0 and 1. Then we have the support vector meshing. Now this is a supervised classification technique that carries an objective to find a hyperplane in an n-dimensional space that can distinctly classify the data points. Then we have the naive Bayes. It is a classifier that acts as a probabilistic machine learning model used for classification tasks. And the crux of the classifier is based on the Bayes theorem. Then we have the k-nearest neighbors. Now, this KNN uses the concept of Euclidean distance to find the similarity of the points where it belongs to. So suppose we have to identify to which class the star belongs to. If k is equal to 3, it would classify it as the black dot, and if k is equal to 5, because we have more number of red dots, the star would be classified as a red colored object. Then we have the unsupervised learning algorithms. So these are used to draw inferences and patterns from input data without reference to the labeled outcomes. So two main methods used in unsupervised learning are clustering and dimensionality reduction. So here these are some examples of unsupervised learning, like organizing computing clusters, social network analysis, market segmentation, and astronomical data analysis. Then we have reinforcement learning. So when a given sequence of states is given, there are some actions that would be performed, and these actions would be rewarded. So based on a negative, if we get a negative reward, then the system would learn, and the next time it would try to learn from its experiences. So some of the examples here are credit assignment problem, game playing, robot in a maze, balancing a ball on your hand. These are a few examples. So here we have the agent environment interface, where the agent and environment interact at discrete steps. So at each state, the agent gets a reward, and based on the reward, it moves on to the next state. So here this game is one example of reinforcement learning, where as the player goes from one level to the other level, the player keeps learning and the difficulty level also increases. So here, machine learning in a nutshell. We have thousands of machine learning algorithms, and each of these algorithms has three components: representation, optimization, and evaluation. So here these are some representations. So we have numerical functions, symbolic functions, instant-based functions, probabilistic graphical models. And we have some search or optimization algorithms like gradient descent, dynamic programming, divide and conquer, evolutionary computation. And then this is the third component, which is evaluation. We evaluate for accuracy, precision, and recall, square error, likelihood. And there are many more that we can use here. These are how we put machine learning in practice. We first of all try to understand the domain based on prior knowledge and the output that we want. And the data that we have will be integrated. It will be selected, that is the feature selection. Then the data will be cleaned and pre-processed, and then we apply the appropriate model, and the results will be interpreted. And these results will be consolidated, and they will be used for discovering knowledge. And this repeats in a loop. So the lessons learned about learning. So we have different learning methods, and we assume different hypothesis spaces. So these are the differences between the supervised algorithms. Logistic regression is fast to train and forecast, but not very accurate. Nearest neighbors is simple and adaptable to the problem, but they are memory intensive. Random forest has high accuracy, but it is slow at training, and there is a problem of overfitting. An unsupervised algorithm like k-means and the principal component analysis. K-means is faster than hierarchical clustering, but requires each data point to have numerical attributes. PCA, which is principal component analysis, can speed up computation. They're simple to understand and use, but it consumes memory and requires all data to be loaded into the memory. So these are the steps in machine learning. So we visualize the data, then we choose the machine learning algorithm, then we choose features, and we figure out the hypothesis using the features. And then we choose the parameters, then the cost function, then find lowest cost using methods like gradient descent, then evaluate the algorithm. Then we must be aware of the bias, and then we apply regularization, test and cross-validate, and the choice of the algorithm depends on the data, the amount of data that we have. So finally, how do we choose a machine learning algorithm? So it is based on three things: the problem statement, size, quality, and nature of data, and complexity. So the problem statement describes the kind of model we will be building. As the name suggests, it tells what the problem is. So let us say the problem is to predict the future stock market prices. So for anyone who is new to machine learning, it will be difficult to figure out the right solution. But with time and practice, we will understand that for a problem like this, supervised learning would be better. Now, the next factor is the size, quality, and nature of data. If data is cluttered, then we go for unsupervised learning. And if the data is very large and categorical, we go for supervised learning solution. And finally, we choose a solution based on the complexity. So if we apply reinforcement learning to predict stock market prices, it would be very, very difficult and time consuming, unlike the supervised learning algorithm. So depending on the kind of data that we have, we apply a particular algorithm. Thank you very much.